the grand organic chemistry. Today we completed alcohols and today we started 9th unit. So far, how much we have done? So the unit 7, basic concepts finished, and unit 8, hydrocarbons and halohydrocarbons done last week. Today we started oxygen containing organic compounds, that is unit 9. 9th unit is oxygen containing organic compounds. Under that, we're going to talk about alcohols, ROH, phenols, benzene joining with OH, carboxylic acid, RCOOH, and then carbonyl compounds, aldehydes, RCHO, ketones, RCOR. Under carboxylic acid, there are 3 other derivatives that we're going to go on. Acid halides, amides and esters. All these are coming under 9th unit. The very first one is the alcohols. Alcohols, common formula we talked about, CnH2n plus 2 OHO, CnH2n plus 1 OHO, CnH2n plus 2 oxygen. And alcohols we can name alcohols with how many OH groups are there? 1 OH group monohydric, 2 OH groups dihydric, 3 trihydric, 4 tetrahydric, many polyhydric. The OH group joint carbon of alcohol is called carbonyl carbon. Physical properties, they have ROH, so that polar compounds, intermolecular interaction is hydrogen bonding, so that when the molar mass, it's hydrogen bonding, but still when the molar mass increases, London force strength increases, so they have water soluble, boiling point is increasing, and also when the surface area increases, also with the London dispersions increasing, boiling point is also increasing. They can make hydrogen bonding with same molecule of each other. And the water solubility, when the carbon number is less than 4, alcohols are water soluble, but above 4, alcohols, with the repelling of this carbon chain, alcohols are water insoluble. And then the most important part is the reactivity. There are 4 different reactions that we're going to go on with alcohols. Yeah, this is a black sheep, but very easily we did today. Any of these alcohol reactions are not difficult. The very first one is the acidity, but acidity of alcohol is less with the inductive effect coming through the R group. Remember, when the inductive effect is greater, acidity is less, so that the highest inductive effect goes to the tertiary alkyl. So least acidity, primary alkyl with the primary alcohol, less inductive effect, highest acidity. But this acidity is less than the acidity of water, because water doesn't have inductive effect, so its acidity is greater comparing to acidity of alcohol. What is the evidence of acidity? Alcohols with sodium reacting with sodium, this is releasing H2 gas, making the salt, but this acidity is less to react with sodium hydroxide, so that alcohols do not react with sodium hydroxide. And then the basicity, they are acting as a Lewis base. These lone pairs on oxygen can donate onto H+, so can protonated on oxygen, so that they are making this basicity. And then carboxylic acid and acid halides, I'm going to get these 2 reactions together. Carboxylic acids and acid halides, what happened here is, both time they are making esters, but in acid halides, this halogen is a good leaving group, so you don't want external driving forces. But for carboxylic acid, to remove this OH and join this alcoholic part, we need to heat up to 80 degrees Celsius or the catalyst conc H2SO4, so that both times they are giving this ester. And then the next one is Grignard. In Grignard, alcohols are acting as proton donor. With Grignard R, they are making alkanes. Next of these reactions, 3 of these reactions are making these alkyl halides, but the Lucas reagent is we are using as an identification test. Lucas means zinc, anhydrous zinc chloride and conc HCl. With that, remember, alkyl halides are highly water insoluble. instant reaction happens with this catalyst zinc chloride, so that tertiary alcohol, this is SF reaction, carbocation stability matters. When the carbocation is more stable, tertiary carbocation is more stable, reaction is very faster. So the medium become turbid with insoluble alkyl halides, and the secondary after 10 minutes and the primary after 1 day, they show their turbidity. So we are using this for the identification or the distinguishing between primary, secondary, tertiary alcohols. And with HBr, remember, with HCl, they show their basicity. Through that basicity, same way here with HBr also, they get protonated. They are joining with hydrogen here. But at the same time, since given this lone pairs away, oxygen gets a plus charge here, alkyl oxonium ion, so that this bond is detaching from it. This RO bond is polarizing towards oxygen. So R gets a plus charge. At the same time, this Br minus donates its lone pair onto R to make this alkyl halides. So that is a reaction. Phosphorus halides, 3 phosphorus halides we are talking about. Each time we are getting same alkyl halide, but the byproducts are different, memorize. Oxidation with strong oxidizing agents and mild oxidizing agent. Strong oxidizing agents are chromate, dichromate, permanganate, CrO3. What happened here is, in acidic medium they are converted into carboxylic acid. In alkaline medium, salt of the carboxylic acid. That's for primary alcohols. Secondary alcohols are converting to ketones. Tertiary alcohols, no reactions with strong oxidizing agents. And then CrO3. Mixing with pyridine as a media and also acidifying the medium, we can make PCC, pyridinium chlorochromate. So this controls the oxidation ability of CrO3, so that PCC converts primary alcohols to aldehydes, secondary alcohols to ketone, tertiary alcohols no reaction. Remember, strong oxidizing agents, primary alcohols, carboxylic acid, secondary alcohols, ketones, tertiary alcohols no reaction, PCC, mild oxidizing agent, primary alcohols, aldehydes, secondary alcohols, ketone, tertiary alcohols no reaction. Then the next reaction is a dehydration, very easy. We did this one for alkene as well, formation of alkene. Any of these reagents, dehydrating agent, H2SO 470, and then P2O5 or alumina or phosphoric, you can use any of this. What happens is H and OH gets away, you are making this double bond. But when the alcohol is asymmetric, through the safe rule, hydrogen gets away from the carbon where hydrogen is less. Those are all those 10 reactions. And then lots of reactions we did for the formation of alcohols, and then we talked about this spider diagram. So we are done here with alcohols. Next day we are starting phenol. Just want to remember, ask you guys to remember, if you guys keep it up, you guys can do this. You know, the grand motto is never ever give up, regardless who discourages you. If you trust yourself that you can do this, you seriously can do this. That is my experience I gained through this my short time of this advanced level. If you trust yourself, if you trust whoever doing this teaching for you, and if you trust the path, trust the process, at the end of the day, you are there. Keep it up. Continue the work. You can do this. This is the Grand Advanced Level Chemistry. I'm Dr. Asha Mathotaarachchi.